Welcome to our math. Today I'm doing a series of videos on higher order polynomials. This says find all the possible real solutions to 2x to the 5th plus 7x to the 4th minus 10x cubed minus 17x squared plus 26x minus 8. Whew, that's a long polynomial. All right, so there is this method, rational zero test, which we can use to find these zeros. It is this really interesting test which says the factors of 8 divided by the factors of 2. So my factors of 8 are 1 and 8 and 2 and 4. And my factors of 2 are just 1 and 2. So the factors of 8 are the factors of 8 divided by the factors of 2 give us all the possible real zeros of this polynomial. So we'll start with 1, plus or minus 1 divided by 1, plus or minus 1 divided by 2. That's 1 divided by 1, 1 divided by 2. Next we'll go to 2. Plus or minus 2 divided by 1. And I would do 2 divided by 2, but 2 divided by 2 is the same as 1. So I don't think I need to write it. It is a duplicate. Now we can go to 4. Plus or minus 4 divided by 1. And 4 divided by 2, unless I'm mistaken, is 2 again. So that's not really needed. Now we go to 8 plus or minus 8 divided by 1. And 8 divided by 2 is just 4 again. So 2, 4, 6, 8, 10. There are 10 options. That's a lot. I mean, that's a lot of options. There are 5 real solutions. And in theory, we have double that many given right here as our options. Now, with that 2 right there, we know we have to have one of the 1/2 because we just do. There has to be a 2x plus 1 or a 2x minus 1. So we know that's one of our options. That just has to be there. That's just the way it works. Probably a 1 is there. That's probably where I would start. And I would use synthetic division versus long division. So if I started with 1, because 1 is simple, we use our coefficients. I have videos on how to do synthetic division, though if I do this enough, you might figure it out. 5, 4, 3, 2, 1, 0. In long division or synthetic, you have to make sure you have all of your descending exponents, which we do. So 2, 7, negative 10, negative 17, 26, and negative 8. Add down, multiply up. Add down, multiply up, add down, multiply up, add down, multiply up, add down, multiply up, add down. We have a 0. So we'll collect these over here. X equaling 1 is a 0. And our resultant, if I were to write it out, polynomial is 2x to the 4th plus 9x cubed minus x squared minus 18x plus 8. So that was one of them. So we have a 0. Let's see. We could try 1 again. It could be multiplicity too. Let's go to 1/2. 1/2. 2, 9, negative 1, negative 18, 8. Half of 2 is 1. Half of 10 is 5. Half of 4 is 2. And half of negative 16 is negative 8. Okay. We've gotten 2. What about negative 1? negative 2, 8, negative 8, negative 4, 4, negative 12. Negative 1 is not a 0. This is getting kind of tedious, right? Like, tedious. We could, if it was given to us, look at the graph. And if we looked at the graph, we might notice that negative 4, negative 2, one half, and 1 are zeros. Now, if you notice, if we crossed to the positive at 1/2, and at 1 we're staying in the positive. So positive, and we're staying in the positive. That means there's a turning point here. Because once we hit positive, we didn't come back to the negative. So at 1/2 we went positive, and at 1 we stayed here. That means there's 2 zeros here. We could test each of these. But at the end, what this means, if we look at it, x equals 1 happened twice. And the other ones we found out were negative 4 and negative 2. This is an even 0 because it happened twice. These are all odd because it happened once. Odd means we cross between even, positive and negative, positive and negative, positive and negative, but at 1 we stayed in positive. That's what an even 0 means. So all of these options were available in our list that we originally came up with, and these end up being our zeros. This is a fun practice, and if you're wondering, could you have just stuck each of these in? 1 is 2 plus 7 minus 10 minus 17 minus 26 minus 8. Probably you could have. I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you in the next video. Thanks!